Using Snap tutorial, Sen2Cor processor on CentOS 7. Open Snap. Go to the menu, Help, submenu, Help Contents. In the Search tab of the Help window, type Sen2Cor and press Enter. Choose the Sen2Cor installation topic, and follow the link for installation instructions. Once the browser opens the link, click on Set a PDF item from the list. This document contains the instructions that must be followed. Install Anaconda, if it is not already installed on the machine. Follow the instructions. Click the download link, choose the installer according to the operating system, and wait for it to be downloaded. Then, install Anaconda according to the default recommendations of the Anaconda installer. Return to the Sen2Cor installation instructions and test your Anaconda installation by opening a command line window and type conda. If the installation succeeded, it should display the helping information about Anaconda. Getting to the Sen2Cor installation, follow the link to download the archive. After the download finishes, extract the archive by using the command line given in the instructions. In the extraction folder, open a command line window and type python setup.py. Install. Follow the instructions by typing the Y letter when it is requested. When the installation finishes, check that the installer created a script file called L2A_bashrc under the Sen2Cor home directory selected during the installation. By default, this location is /home/username/Sen2Cor. Now, the installation instructions present two ways to use this script. The first option is to call the script via the bashrc, or profile, script files, located under your user home directory. And the second option is to call the script manually each time a new terminal is opened, and any operation that needs to use the Sen2Cor should be opened in the same terminal. Next, in this tutorial, we will use the first option, since it is enough to set up for the first time. Depending on the operating system, the solution is to call the Sen2Cor bash file, either via the bashrc, or the profile system file. On the current platform, which is a CentOS 7, the profile script is executed on startup or login. So it will be enough to log out or restart the operating system. Instead, the bashrc script is executed when a new terminal is opened, so the Snap application will need to be started by using a terminal, and, in this case, a restart or logout is not necessary. Depending on preferences, one option or the other can be used. In this tutorial, the option with the logout action will be presented. So, let us edit the profile file. If the file is not available under the home directory, create it and edit by editing the L2A_bashrc file execution, with the location of the file, relative to the profile file location. Next, log out or restart the operating system. When the system starts again, test the installation by calling the processor via L2A_process --help in a new terminal. If no error is received, the installation is successful. So we installed the Anaconda and the Sen2Cor. Now we need to integrate Sen2Cor with Snap, so that we can use it in Snap. Open Snap, and go to the menu, Tools, submenu, Plugins. In the Plugins window, go to the tab Installed. If the Sen2Cor processor is available in the list, check it and press the Uninstall button. Restart the Snap application. In the newly opened Snap, go again to the menu, Tools, submenu, Plugins. In the Plugins window, go to the tab Available Plugins. Check the Sen2Cor processor and click the button Install. Follow the installation instructions, accept the message stating that the plugin is not signed, and click the button Finish to restart Snap again. Launch Snap and go to the menu, Tools, submenu, Manage External Tools. In the Tools table, click the Sen2Cor processor and click the button Edit. In the editing window, check the System Variables area, and see if the three values were updated with the local paths of the two tools just installed. If not, this means the script file created by Sen2Cor application was not executed by the system. In this case, we can try the other option, which means to move the script execution from the profile file to the /rc file. Then, close the Snap application, and open a new terminal. Go to the Snap application installation directory, and run Snap from the terminal. This should solve the problem, and this time the locations should be populated. Open a Sentinel product, Level 1C. Choose the resolution and the coordinate system. Wait for the product to load. After the product is loaded, go to the menu Optical, submenu Thematic Land Processing, submenu Sen2Cor. The Sen2Cor window is the window of a classic Snap operator, having two tabs, Input-Output Parameters and Processing Parameters. In the first tab, choose the source product as the product we have just opened. The target product usually represents the product created by the process. But the Sen2Cor processor will always create his output in the same location as the input product, and with similar names. Since the target product properties are not used by Sen2Cor, there is no need to fill in the name, the saving format in the location. Snap, however, can figure out the output product location to try to open it, so we want to leave the Open in Snap check. Next, Processing Parameters tab contains the resolution and the velocity template file for post-execution. You should change only the resolution value according to the one of your input product. Finally, check Display Execution Output to be able to see the Sen2Cor processor output messages, and click Run. This step may take a while, so be patient. When the operation finishes, check if the Level 2A product was opened in Snap. If not, this can happen according to the process exit code. We can check if the product was created in same location as the original product. The output product file will have the same name as the input one, but with L1C replaced by L2A, and OPAIR replaced by user. If the product is present, open it in Snap. Otherwise, please address the issue to the STEP forum. Open the same band in the original, and in the processed product. Check the pixel values in both bands, and we can see the values are changed according to the atmospheric corrections. Thank you for watching.